Hello, AP Stats students, and welcome to session 7 of AP Daily live review for AP Statistics. My name is Luke Wilcox, AP Statistics teacher from East Kentwood High School in Kentwood, Michigan. Now, in this session, we are going to focus in on the one question that we are guaranteed that we know to see on the AP exam. That is free response question number 6, called the investigative task. Now, I think that this one question has the potential to increase your AP score by 1 full point. So we're talking, if you're a 2 right now and you do well on the investigative task, you're going to be a 3. If you're a 3 right now, we can bump that up to a 4. And now where I think most of you are is that you're a 4, and we're going to try and bump you up to a 5. So if you like that idea, then stick around, because I'm going to give you 5 specific strategies on how you can tame the investigative task. So let's start with a few logistical items. The first, if you've been with us for the last few sessions, you know that all of the materials, the handouts, are available at this tinyurl.com/AP Statistics 2021 review. That link is also down below in the YouTube description. And what you will find there, and what you will need for this session, is the session 7 handout, along with the formula sheet and the tables that you will be provided on the AP exam. So go there right now, grab that session 7 handout. It has everything that you will need for this session. Now, as usual, at the end of the session, I am going to ask for your feedback so that we can see what's going well and what things we might still be able to work on. Now, speaking of that feedback, Mr. Starnes and I have been paying very close attention to that feedback that you've been giving us. And what I did today was I looked back at the last 2 days of feedback, and I tried to summarize some of the most common questions that I was seeing there. So here are a few of them. The first one was, can you share the inference procedure flowchart? Now, that was presented in session 5. And of course, the answer here is yes. We definitely want to give you access to that. So in that Google folder, you are going to find now a couple of things. One that I want to remind you of, Mr. Starnes talked about it in the last session, but there is now an alignment guide, so that if you want more help, you can find other AP daily videos that correspond to the questions that you're struggling with. And you can see here, we have them for each one of the sessions, including this session, session 7. And then the other thing that you're going to find here in this folder now is the inference procedure flowchart, which looks like this, that you now have access to. And actually, we're going to use this flowchart when we dig into a practice question later on in this session. So back to our student feedback here. The next question that I saw quite a few times was students wanted help understanding the difference between a binomial random variable and a geometric random variable. Now, we did some example problems with binomial, but we never talked about geometric, and you got to know the difference between those two. So here it is. A binomial random variable is counting the number of successes in a fixed number of trials. So for example, maybe we toss a coin 50 times, and we are counting the number of heads out of those 50 tosses. And the important thing there is there's a fixed number of trials. There's 50 tosses of the coin there. Each one of those tosses has the same probability of success of 0.50. So that is a binomial random variable. A geometric random variable is counting the number of trials until the first success. And so there is no fixed number of trials here. So if we were concerned with the number of coin tosses that was needed until we got the first heads, that would be a geometric random variable. So the biggest difference between the two is that a binomial random variable has a fixed number of trials, whereas geometric random variable, there isn't a fixed number of trials, because we're just counting the number of trials until the first success, and we don't know how long that's going to take. Now, one of the other questions that came up a lot in the feedback was about conditions for inference, specifically conditions for confidence intervals and significance tests. Now, Mr. Starnes and I have gone over a couple of FRQs with confidence intervals and significance tests, but I wanted to give you just sort of a general overview about what conditions need to be included anytime you're doing inference. And really, there's 3 conditions that you always want to think about, okay? The first condition is the random condition. And there's a couple of different ways that this could be satisfied. The first is if you have a random sample. And the reason why a random sample is important is so we can generalize to a larger population. So if you have a random sample, you know that you can generalize that random sample to some larger population. Now, on the other hand, you might have an experiment that utilizes random assignment. Now, this is important for a different reason. And the reason is if you have random assignment in an experiment, that's what's going to allow you to show causation in the end. So this one is so we can show causation. Now, there is a slight possibility that you might have both of these. You might have a random sample of something, and then there's also an experiment with random assignment. You just want to make sure that you're always checking for both of these for the random condition. Now, the next condition that you want to think about is the 10% condition. And you only need to check the 10% condition when you are sampling without replacement. Okay, if you're sampling without replacement, you got to check to make sure that that sample size is less than 10% of the population. And if the sample size is less than 10% of the population, then we're okay, even if we're sampling without replacement. Now, if you have an experiment that is utilizing volunteers for the experiment, which is quite often the case, if they're volunteers, that's not really a random sample, in which case there's no need to check the 10% condition. And then the third condition is going to be something about the sampling distribution that you're going to use for inference. And it's about the shape of the sampling distribution. And typically, we'd like to know that that sampling distribution is approximately normal, or for a chi-square test, that it's approximately chi-squared. And there's a couple different ways to check that depending on which world you are in. If you are in the world of proportions, you are going to check the large counts condition. That is n times p greater than or equal to 10, n times 1 minus p greater than or equal to 10. That's your successes and failures have to be each greater than or equal to 10. And the reason that's important is so that the sampling distribution is approximately normal. Now, that's the world of proportions. In the world of means, we call it the normal large sample condition. And there's actually 3 different ways that you can check that condition. And I want to remind you of these 3 different ways. The first one is kind of the easy one. If they tell you in the problem that the population distribution is approximately normal, then we know that the sampling distribution is approximately normal. So number 1, if the population distribution is approximately normal. Now, if they don't say anything about the population distribution, or you don't know anything about the population distribution, the second way that you can satisfy this condition is if the sample size is large enough. And typically we say n has to be greater than or equal to 30, which allows us to use the central limit theorem to say that the sampling distribution is approximately normal. Now, the third case is if you don't know anything about the population, your sample size isn't large enough, so it's less than 30, you're going to have to graph the sample data. And what you'd like to see in that sample data is that the sample data shows no strong skew or outliers. So those are the 3 ways that you can check the normal large sample condition when you're doing inference for means. Now, for chi-squared tests, there is a large counts condition, and it would say that all of the expected counts are greater than or equal to 5 or 10, depending on which textbook you use there. So that's the third condition that you might have to check there. So you're always going to want to think about these 3 conditions anytime you're doing an inference procedure, like a confidence interval or a significance test. Now, if you've been watching along, you know that Mr. Starnes likes to give the warm fuzzy from the student feedback. Well, obviously this student was aware of what Mr. Starnes was doing because this student called it the little fuzzy wuzzy. So that is the student's words, not my words. But I certainly appreciate those words of feedback from whoever this student was. And I hope that this has been a helpful review for all of you. Okay, so let's talk about what we're going to learn in this session number 7. So here's the plan. In order to tame the investigative task, here's the general approach that we're going to take. First, I'm going to present some quick facts so that you know about the investigative task, and then I'm going to discuss my suggested strategies, and I have 5 of them for you. And then after we've talked about those strategies, I want to try and show you what those strategies look like in action. So we're going to actually go back to 2 investigative tasks from previous AP exams, 2009, 2019, and we are going to work from the start to the finish, that entire investigative task, so that you get that experience of seeing what that looks like and what that feels like to go through a couple of investigative tasks. Now, as usual, we're keeping the same goals that we've had for the entire review sessions here. And that is first to try and simplify some challenging content. Next, we want to share specific strategies that will help you for AP exam success. And hopefully by the end of this whole thing, we are definitely building your confidence for the AP exam. So let's go ahead and jump right in. I'm going to start with the quick facts about what the investigative task is here. All right. Now, this is what it looks like on the AP exam. You're going to see it exactly like this, but let me sort of get you oriented about what you can expect on the AP exam. There are two sections. Okay. The first section, section 1, is where you're going to do the multiple choice questions. And there are 40 multiple choice questions. And you have 90 minutes to complete those 40 multiple choice questions. Section 2 is where we move to the free response questions. And once again, you get 90 minutes, but this time you have 6 free response questions to go through. Now, question number 6 right here, part B, that is what we call the investigative task. It is the very last free response question. And you can see here that it says you want to spend about 25 minutes on this part of the exam. That is a suggestion. And so for those 6 free response questions, if you think about the timing of this here, numbers 1 through 5 are all about the same length there. Question 6 is definitely longer than the others. And you can see question 6, it is recommended that you spend 25 minutes. Now do some quick math here. If you have 90 minutes for the free response and you take 25 minutes on question 6, that leaves you with 65 minutes for the other 5 questions. So on average, you're going to need about 13 minutes for each one of those 5 questions. Okay, so you can see question number 6 is definitely longer than the other free response questions. And here's the big thing. It is worth 25% of the free response score. So that actually means that overall, it is worth 12.5% of your AP exam score. That is one question on the AP exam is worth 12%. So this is where you can increase your AP score by 1 is by doing well on the investigative task. Now, what is the investigative task? I haven't quite revealed that yet. Well, if you look on the College Board website, they're going to tell you that the investigative task assesses multiple skill categories and content areas, focusing on the application of skills and content in new contexts and in non-routine ways. So new contexts in non-routine ways. Now, let me tell you what that actually means. That means they're going to give you something that you have never seen before, okay? This was not part of the course that you took. It was not in your textbook. You did not do a homework problem like this. It was not in the amazing review that Mr. Starnes and Mr. Wilcox put together. It is going to throw something at you that you have never seen before. But it will be something that you can do using the thinking and reasoning that you've developed throughout the school year. So there's a lot of statistical thinking and reasoning skills that you've developed this year. This is where we're going to put those into play. So even though you haven't seen the content before, you do have the thinking skills that are needed in order to do the investigative task. So let me give you my 5 strategies for success on the investigative task here. Okay, the first one, super important, is that you don't freak out. I can't tell you how many times early in my career when I was a young AP stats teacher, my students would come back the day after the exam and they would say, Mr. Wilcox, question number 6, I had no clue whatsoever. Well, I hadn't prepared my students for that. I didn't know enough about what the investigative task was. I should have done a better job to prepare them so that they knew that question 6 was going to be something new, something they'd never seen before, so that you can remain calm as you work your way through question number 6. Another quick story here, as an AP exam grader, I have graded question number 6s before, and I can't tell you how many times students will do just fine on part A, do just fine on part B, but as soon as they get to the investigative part of the question, they just give up. They put their hands in the air and there's nothing written, okay? You can't do that. You gotta have stuff written down. This question is worth so much of the AP exam. So it is important that you stay calm even when you enter the investigative part of the task. Next, you need to expect that the questions will span several units in the course. Okay, while the other 5 free response questions, each question might live in a little bit smaller content area. Like you can expect one question to be a significance test. There might be one question that has something to do with 2 variable data. In the investigative task number 6, you might get a question from 1 variable data, you might get a question from sampling designs, and then another question from statistical inference. It is going to span the length of the course. And you can expect that a part of it is probably going to be about inference. So something related to a confidence interval or a significance test. Next up, you got to make sure that you get the easy points. Okay, the investigative task is going to start you in the world of known. Okay, part A, part B is generally going to be something that you did cover in the course, something that you have seen before. You got to get your points on those parts, on the easy parts. And you'll see that once we take a look at a couple of examples. My next suggestion to you is that the investigative task almost always has 4 or 5 or 6 parts. And a lot of times the later parts require you to use your answers from the previous parts. Now, if you get stuck and you don't have any clue how to do part C and part D, but you need those answers for part E, you got to make something up. Make up a reasonable answer, something that's reasonable. So don't give me a probability that's negative, but make up a reasonable answer so that you can use that in the later part where you can still get credit even if your previous answers were incorrect. And then finally, a lot of times the investigative task is going to have a final part, a final question that asks you to sort of look back at the work that you've done so far and summarize what you've done. And so if the question specifically asks you to reference previous parts of your answer, make sure that you specifically reference the previous parts of your answer there. So now that you have these 5 strategies in mind, I really want to show you what these strategies look like in action. And so we're going to take a look now at some actual investigative tasks from previous AP exams. And I'm going to start you out here in 2009 with the investigative task, and you will see this on the session 7 handout. So here's what the question says. A consumer organization was concerned that an automobile manufacturer was misleading customers by overstating the average fuel efficiency measured in miles per gallon, or MPG, of a particular car model. The model was advertised to get 27 miles per gallon. To investigate, researchers selected a random sample of 10 cars of that model. Each car was then randomly assigned to a different driver. Each car was driven for 5,000 miles, and the total fuel consumption was used to compute the MPGs for that car. Part A, define the parameter of interest and state the null and alternative hypotheses the consumer organization is interested in testing. Okay, this clearly sounds like we're trying to do some statistical inference here. So the first thing we want to think about is what type of inference procedure do we need? And I'm going to take you to the flow chart in just a moment here, but I've highlighted a couple of important words that we see in the question here. The first of which is this word average, which tells us we're in the world of means. And then also that we just have one random sample of 10 cars here. And then finally, it sounds like we're going to be doing a significance test here rather than a confidence interval. So if I go over to my flow chart here, let's go through the questions here. The first question, which inference procedure? Well, we got to check for special cases first. And this is definitely not about slope of a regression line. It is definitely not a chi-squared test with a table of frequencies. So we are over here, are we in the world of proportions or the world of means? And we decided that we are in the world of means. And then how many samples or how many groups? Well, we said that there was just one sample of 10 cars here. And then finally, the last question, is this a test or is this an interval? And based on the wording of the question, this is going to be a significance test. And so we're deciding here that it is a one mean t test. All right, so we know right away that this is a one mean t-test or a one sample t-test, depending on how you want to state that. Now let's answer the question, part A here. We need some hypotheses. So we definitely need a null and an alternative hypothesis here. Because this is the world of means and we have one mean, the parameter that we're going to be using here is mu. And the null hypothesis here, if I look back at the wording of the question, it was advertised to get 27 miles per gallon. So the null hypothesis here is going to say that that true mean miles per gallon is in fact 27. Now, when we think about the alternative, we need to decide whether it's one-sided or two-sided, and that's going to depend on the wording of the question. Now here it says that they think that they are overstating the average fuel efficiency. So if it's overstating, then we think that the true mean is actually less than 27. So that is a one-sided significance test. Now we also need to define mu. If we're using mu in our hypotheses, we need to say what mu represents. So mu represents the true mean miles per gallon for all of this particular car model. Now, just to point out a couple of common student errors that are made here. A lot of times students, when they're writing their hypotheses, will use X bar instead of mu. Now, X bar is referring to the sample mean. When you write hypotheses, you have to refer to a population mean. So you definitely want to use mu here rather than X bar. The other common student error when defining the parameter, sometimes students will refer to the sample. They might say true mean MPG of the sample. Well, that's not what mu is. Mu is the true mean MPG for the population of all of this particular car model. So just be careful of that. Now, this right here is one of the strategies that I talked about, which is to get the easy points. This is definitely something that we did during the course. You know how to write hypotheses. You know how to define parameters. You got to get your easy points here on part A. Now let's move to the next part. It says one condition for conducting a one-sample t-test in this situation is that the MPG measurements for the population of cars of this model should be normally distributed. However, the box plot and the histogram shown below indicate that the distribution of 10 sample values is skewed to the right. Part B, one possible statistic that measures skewness is the ratio of the sample mean to the sample median. What values of that statistic, small, large, or close to 1, might indicate that the population distribution of MPG values is skewed to the right? Explain. Okay, so there's a couple of things that we need to think about here. Very clearly, you can see in the graphs here that this is skewed to the right. And when we have distributions that are skewed to the right, that is typically going to impact the mean more than the median because the mean is non-resistant. And the mean is going to get pulled in the direction of the skew, in this case to the right, which it means that it's likely that the mean here is going to be greater than the median. Now, if you think about this, if the mean is greater than the median, and we're taking a ratio of the sample mean divided by the sample median, what we have here is something that's larger on the top of the fraction than on the bottom of the fraction. And so this is going to be greater than 1, right? If the larger value is on top, smaller values on the bottom, we got to get a ratio here that's greater than 1. So we would say, I guess, large or greater than 1 here because the distribution is skewed to the right. Now, notice here that this is starting with something that we definitely know from the course. We know that the mean is greater than the median for a skewed right distribution, but it's starting to transition into the investigative task because they've asked you now about something that you haven't really seen before or maybe thought about, but it's definitely something we can understand with our previous knowledge about the mean being greater than the median. All right, let's jump to the next part here. It says, even though the MPG values in the sample were skewed to the right, it is still possible that the population distribution of MPG values is normally distributed and that the skewness was due to sampling variability. To investigate, 100 samples, each of size 10, were taken from a normal distribution with the same mean and standard deviation as the original sample. Okay, they're saying here that these samples were taken from a normal distribution. That's going to be important. For each of those 100 samples, the statistic, sample mean over sample median, was calculated. A dot plot of the 100 simulated statistics is shown below. Okay, before we move on, I just want to make sure that we understand what this dot plot is giving us. So one of those individual dots, like that dot there at 0.97, that represents one sample of 10 cars. And what they've done is they've calculated the sample mean divided by the sample median for that one sample under the assumption that the population distribution is a normal distribution. So it's not surprising that at the center of this distribution, we get 1, where the mean would be equal to the median. But certainly, every time you take a sample, that statistic is going to slightly vary. So it might be a little bit greater than 1, might be a little bit less than 1. So we actually have a sampling distribution here for a statistic that we've never studied before. So here's the question. It says, in the original sample, the value of the statistic was 1.03. Based on the value of 1.03 and the dot plot above, is it plausible that the original sample of 10 cars came from a normal population, or do the simulated results suggest the original population is slightly skewed to the right? Explain. Okay, let's take a look at the dot plot here, and you'll see that 1.03 was the value from the original sample. So the question is, under the assumption that the population is normal, is it possible that we would get that ratio purely by chance just due to random sampling? And you know what? I see a lot of dots there that are as large as 1.03 or even greater than 1.03. And in fact, if I count those up, that's 14 out of the 100 simulations are giving me a ratio of 1.03 or greater. This is 0.14. Now, hopefully you recognize what we've just calculated right here. This is the holy grail of AP statistics. We talked about this in an earlier session. This is the estimated p-value for a significance test. So if we were to think about how to interpret this p-value, we would say something like, assuming that the population is normal and we're taking random samples from a normal distribution, there is a 0.14 probability of getting a ratio here of 1.03 or greater purely by chance. Now that 14%, that's greater than a typical significance level of 5%. So I think we can arrive at an answer here now. We're going to say, because that simulated p-value of 0.14 is greater than 0.05, we do not have convincing evidence that the population distribution is skewed right. So we do not have convincing evidence that the population distribution is skewed right. Therefore, to answer the question here, we do think that it is plausible that the sample came from a normal distribution. Now let's reflect back on what just happened here. This definitely moved us into the investigative part of the task. This is definitely something that we didn't study in the course. But with an understanding of sampling distributions and what a p-value is, we were able to write a conclusion that looks similar to other conclusions that we've written for significance tests. All right, let's move to part D here. It says the table below shows summary statistics for MPG measurements for the original sample of 10 cars. So it looks like we're given the 5-number summary there: minimum Q1, median Q3, and maximum. It says choosing only from the summary statistics in the table, define a formula for a different statistic that measures skewness. What values of that statistic might indicate the distribution is skewed to the right? Okay, right away here, I'm seeing the 5-number summary, and that's making me think about a box plot. So let me just quick make a box plot here. And let's see, I'm going to need to have values maybe as low as 20. And I got to get at least to 30 or 32 here. So there's 30. I know I need a little bit past that. So if I look at those 5-number summaries, the minimum is at 23. So I'm going to go to 23 here, put my dot. The Q1 is at 24. The median is at 25.5. The Q3 is at 28. And the maximum is at 32. And so now I want to draw my box plot. So I need my whiskers here, and then I need my box. So there is my box plot. And just by looking at this box plot, it does suggest to me that we have a skewed right distribution, because you see like the right side tends to be a little bit longer than the left side there, right? And so we need to come up with a statistic for measuring skewness. And there is more than one correct answer here. But let me give you one way that we could think about this. We could look at the left side of this box plot and compare it to the right side of this box plot. And clearly you can see the right side of that box plot is bigger than the left side. Now that right side there, in order to calculate that, what would we do? We would take the maximum value and we would subtract the median. So that's the distance from the median to the maximum. And then on the left there, I would take, let's see, the median, and I would subtract the minimum value. And we're saying that the part on the right is bigger than the part on the left. So using a similar reasoning that they did earlier in the problem, if I were to take a ratio here where I took the maximum minus the median, that's the part on the right, and I divided it by the part on the left, which is the median minus the minimum, well, because the bigger value is on the top, this ratio should be greater than 1 for a skewed right distribution. So there I have made up my own statistic. It is a single value that can be calculated from the sample. And I'm saying if that statistic is greater than 1, then that suggests we have a skewed right distribution. Now, certainly that is not the only correct answer here. A couple other answers that you could provide, you could actually look at, say, this distance for the right whisker and compare it to the distance from the left whisker and look at the ratio. And once again, that would be greater than 1. Or you could even just take this part of the box and this part of the box and say that the right side divided by the left side is greater than 1. So there is more than one correct answer here. So definitely this is an investigative task right here because we've never done this before in the course. There is more than one correct answer, and that's okay. Now, the other thing I want you to recognize, now that we've completed this investigative task, that is the end of the investigative task, is that it does span the entire course. So while we have some one variable statistics here and box plots, which we did very early in the course, it also had a question about inference with understanding a p-value and making a conclusion to a significance test. So it definitely spanned the length of the course here. So that takes us through 2009. I'd like to move us to a more recent investigative task. One of my favorite questions, the 2019 investigative task, number 6 in the free response. So here's what it says. Emma is moving to a large city and is investigating typical monthly rental prices of available one-bedroom apartments. She obtained a random sample of rental prices for 50 one-bedroom apartments taken from a website where people voluntarily list available apartments. Describe the population for which it is appropriate for Emma to generalize the results from her sample. Okay, I see that word generalize, and we're trying to generalize to a population from a sample. This sounds familiar to me. We have definitely studied this in AP statistics. In fact, I'm going to bring you back to a picture that I drew in an earlier session, which is the idea that the population is this large cloud that you see here. And if we have a random sample or an SRS, it should be representative of the population. So it should look like the population. So I'm going to draw a small cloud here, which is an SRS or a random sample. And we know from the question that we do have a random sample. So the question is, what is the population here that we're trying to generalize to? And you can see in the wording of the question here, this is a random sample of rental prices for 50 one-bedroom apartments taken from a website where people voluntarily list available apartments. Essentially, they're telling us the population there. So the population is one-bedroom apartments. Okay, I can't generalize to all apartments. And it is only apartments taken from this particular website from the people that volunteer to list their apartments on this website. So let me show you in words what the final response should look like here. It says, because random sampling was used, the results of the sample may be generalized to the population of rental prices for one-bedroom apartments, it's got to say one bedroom, in the city that are listed on this particular website at the time the sample was taken. So that there is the population that we can generalize to. So once again, AP or investigative task strategy, you got to get the easy points. This is a question about stuff that we definitely studied in the course. So you want to get your credit here in part A. Now, moving to part B, it says the distribution of the 50 rental prices of the available apartments is shown in the following histogram. Emma wants to estimate the typical rental price of a one-bedroom apartment in the city. Based on the distribution shown, what is a disadvantage of using the mean rather than the median as an estimate of the typical rental price? Okay, based on this histogram that I see here, I can clearly say that this data is skewed to the right. And actually, we just talked about this in the previous investigative task. We know that in a skewed right distribution, the mean is going to be greater than the median. Okay, and it could potentially be affected by these potential outliers. I've got these couple values here. Those are potential outliers. And we know that an outlier has a large impact on the mean because the mean is non-resistant, which is going to draw that mean to the right, such that the mean is greater than the median. And so we think that the median is probably a better measure of the typical rental price. So we would like to use the median for the typical rental price. The mean is not going to do as good a job because it's going to be pulled to the right. So to summarize the answer, we would say because the distribution of 50 rental prices is skewed to the right, the sample median provides a better indicator of typical rental prices than the sample mean. Some very large rental prices result in a sample mean that is substantially larger than the more typical rental prices. Now, very important, the last part of this. As a result, the sample mean would overestimate the typical rental price, whereas the sample median would be a more accurate representation of typical rental prices. Now, what we're doing there in that last sentence is that we're making sure that we answer the question that is being asked, which is to provide a disadvantage of using the mean. So this is a strategy I've taken from Mr. Starnes, but he calls it ATQ, which is to answer the question. And in order to answer the question, you have to read the question. So RTQ, read the question, and answer the question. So make sure that you've addressed the disadvantage of using the mean rather than the median. Now, once again, this isn't really an investigative part of the task. This is something that we should be able to do from what we learned in AP statistics. We know about skewed distributions. We know about mean relative to median. So let's move into part C. It says, instead of using the sample median as the point estimate for the population median, Emma wants to use an interval estimate. However, computing an interval estimate requires knowing the sampling distribution of the sample median for samples of size 50. Emma has 1 point, her sample median in that sampling distribution. Use information about rental prices that are available on the website. Describe how someone could develop a theoretical sampling distribution of the sample median for samples of size 50. Okay, we're supposed to talk about how to come up with a sampling distribution, and we definitely studied sampling distributions in this course. Now, we didn't necessarily study sampling distributions for sample medians, but using what we know about sampling distributions, we should be able to come up with this. And the idea of a sampling distribution is that you have many, many samples. And each time you collect a sample, you calculate some statistic. In this case, the statistic is going to be the sample median. And you're going to do that over and over and over again for many, many samples. In fact, in order to be the theoretical sampling distribution, we would have to have all possible samples of size 50. So here's our final response here. To determine the sampling distribution of median rental prices for random samples of 50 one-bedroom apartments from this population, Emma would need to obtain every possible sample of 50 one-bedroom apartments from this website and compute the median of each sample. The collection of all possible sample medians is the theoretical sampling distribution for the sample median. Now, very important, in order to get full credit here, you have to talk about taking every possible random sample, and you have to talk about computing the median for each one of those samples in order to build the sampling distribution. So this has definitely moved us into the investigative part of the task. But hold up, wait until you see the next part here. Okay, it says, because Emma does not have the resources to develop the theoretical sampling distribution, she estimates the sampling distribution of the sample median using a process called bootstrapping. Now, hold up. we didn't study bootstrapping in this course. This is the moment when students often freak out because they see something that they've never seen before. Let's stay calm and read on, because this is definitely something we can do with what we have learned in the course, even though we don't know what bootstrapping is. So here's what it says. In the bootstrapping process, a computer program performs the following steps. Take a random sample with replacement of size 50 from the original sample. Calculate and record the median of the sample, and then repeat this for a total of 15,000 medians. Emma ran the bootstrap process, and the following frequency table is the bootstrap distribution showing her results of generating 15,000 medians. Okay, here is the table that was provided for this question here. And what you can see is all of the different sample medians that were obtained and how many times that sample median occurred. And so you'll see the frequencies in those three columns there. How many times did each one of those medians occur? And if we were to total up all of those frequencies, we're going to find that the total number of medians, it's given to us in the problem, the total number of medians that are represented in this table is 15,000. There were 15,000 different random samples here. Okay, so let's go back to the question. Here's what the next part says. The bootstrap distribution provides an approximation of the sampling distribution of the sample median. A confidence interval for the median can be constructed using a percentage of the values in the middle bootstrap of the bootstrap distribution. Part D, use the frequency table to find the following. So first, the 5th percentile. Okay, we know what a percentile is, right? If we have all the numbers in order, the 5th percentile is the value that has 5% less than or equal to that value. So let's think about that. We know there's 15,000 values, and we want to find the 5th percentile. Well, 5% of 15,000 is 750. So we're looking for the value in the 750th position. Well, let me go back to that table there. I need to find the number in the 750th position. So I'm going to start at the low end. I have one of those medians, and then I have 13 of those medians, and I'm going to start to get a cumulative total for all of these here. So the 1 plus the 13 is going to give me 14. And then I move down and I add in the 18, and that's going to give me 32. And then I add in the 56, and I'm going to get 88. And then I add 4, I get 92. And then 148. And then 203. And then 206. And then 272. And then 408. And then a big jump here takes me to 2307. And the question is, where is the 750th value? Well, we know where the first 408 values are. So the next values, the next 1,899 of them are all 2,500. So that right there is the value that is the 5th percentile. So I'm going to go back to my answer here and say that that value was $2,500. Now, similarly, we can do the same thing for the 95th percentile. If you take 95% of 15,000, this time you're going to get 14,250. So we need to find the number that is in the 14,250 position. Now, we could start adding up all of those frequencies, but it actually works better to work backwards from the end. And I'm just going to start doing the same thing here where I'm calculating the cumulative totals working backwards. And I know I have to go 750 values backwards here. So if I continue my cumulative values here, let me record these: 89, 95, 188. Now here's where we make the big jump to 888. And so where is 750 back? Well, it's definitely going to be here at 2950. That is going to give us our 95th percentile. So when I go back here, I know that value is 2,950. Okay, part E. Find the percentage of bootstrap medians in the table that are equal to or between the values that you found in part D. Okay, the values we found in part D are 2,500 and 2,950. And so what we're actually looking for here is the frequency. How many of them are between 2,500 and 2,950? So if I look at all these frequencies, I really want to add up all the frequencies between those two values, including the endpoints. Now, in actuality here, it's going to be easier to find the other values here. And in fact, we've already calculated the cumulative total of those as 408 and the cumulative total of all of these as 188. And so we can take the 15,000 values and we can subtract out the 408 and the 188. And that's going to tell us there are 14,404 values that are between 2,500 and 2,950. And so that's 14,404 all divided by 15,000. And that is about 96% there. And this takes us to the final part. Use your values from part D and E to construct and interpret a confidence interval for the median rental price. Okay, we've never done a confidence interval for a median, but we know we need to use our answers back here. Now, strategy, if you didn't have an answer for D or E, this is where you're going to make up a number so that you can use it for part F, okay? And in part F, hopefully you realize that we can calculate a 96% confidence interval here. And we know how to interpret a confidence interval. It looks just like this. We are, now in this case, we're going to say 96% confident that the interval from, now if we look back at our answer for part D, the interval is going to go from $2,500 to $2,950, captures the true median price, and this is where we'll put the context, of one-bedroom apartments in this city on this website. So that interpretation of a confidence interval is very familiar to us. We just had to fill it in with the information from part D and from part E. So that's an example of where the final question in the investigative task asks for a summary of what you've done previously there. So that finishes our second investigative task. I'd like to reflect a little bit here and talk about what you should take away from this session here. So the first thing we're trying to do here is to simplify challenging content. And we definitely talked a little bit about sampling distributions in each one of those investigative tasks. You have to understand the idea, the concept of a sampling distribution. Now, you also notice that in these investigative tasks, they almost always have at least one part that is statistical inference, a confidence interval, or a significance test. And then bootstrapping, we didn't know what that was before we started this problem, but hopefully after going through the investigative task, you have a little bit better understanding of what bootstrapping is. Now, let me review those 5 strategies for the investigative task. Number 1, probably the most important, is that you don't freak out. You don't quit. You persevere through that entire problem. Number 2, you can expect that the question is going to span the entire course from the beginning to the end and even in the middle. Next, you got to make sure you get the easy points. Part A, part B, that is in the world of known. You got to get your points in the world of knowns. Next, if you get stuck and you need an answer for a later part, just make up an answer, just make sure that it's reasonable. And then finally, that last part of the investigative task is often going to ask you to summarize what you learned in the investigative task. So hopefully this session has made you more confident and not so much anxiety around the investigative task, and that we are starting to build your confidence for the AP exam. Now, I'd love to hear from you, some feedback on how this session went, what was valuable, what we could do differently for our session tomorrow. Also, if this session was helpful for you, please give me a thumbs up in YouTube so that we can bring this message to other AP statistics students. So thank you all for joining me for this session. Tomorrow is our final session. Both Mr. Starnes and I will be there, where we are going to give you our top 10 AP exam tips. It's going to be our best session yet. You don't want to miss it. So hope to see you again in session 8. Thank you.